So this is the main emulator. This here is the chassis. Chassis is divided into 3 tiers. Each tier has 10 slots. These 2 slots are fixed. You can't change what's in there. Everything else, you can move things around, you can add devices, create your own devices to add them. Devices like this, here's the CPU, spans multiple slots. The data entry hex keypads spans multiple slots. Then we've got some 1-slot devices here. This is some memory for the machine. Some LEDs arranged as a traffic light display. This here is some magic locations, so a real-time clock, random number generator, etc. Paper tape reader, which we don't need. This at the bottom here is a debug terminal that the CPU, this module here, gives us if we want. We can interact with the CPU, so interrogate registers, the status registers, change bits in the status register, dump memory, fiddle with the register values, etc. This section here will show us the instruction pipeline and the nibbles that the instruction is loading from memory. This here has the option to display the assembler listing that goes with the hex code that's been loaded. So as the machine is stepping through the hex code, we can actually see the original lines of assembly that generated those hex codes here, so it makes following the program a lot easier. On the left we have the virtual printer. This spools to a file, so you can keep the printout or you can delete it, or you can actually also send it to a real printer if you so wish. So this emulator has been loaded with our traffic light test program. We switch on. The CPU and the chassis are actually dumping out the system configuration here, so we can see what devices are loaded, their addresses in memory, versions, description, etc. If we go load here, this is our assembler source code. If we start to you see the program counters at 0, stat pointers at 500 hex, etc. If we start to debug this, as we debug, this displays as the current line we're at. You can see the program counter, the values of the registers, the status bits, etc. And because we've got debugging switched on, as well as this display here, we get a printout, a trace of exactly what happened. Here we can see the pipeline. So when we read the instruction at location 6, we then pulled in these nibbles which made up the instruction. This has been valuable for debugging some of the instructions. And as we step through, you can see it moves. We can put this into run mode to let it just run. If we watch the traffic lights, red, red, amber, green, second delay, amber, red, back to halt, and that's it.